The objective for this lesson is I can use visual models to add two fractions with related units. So in the past couple lessons, we were adding fractions that had like units, so they had the same denominator. This time we're going to be adding fractions with related units. In other words, the denominators are going to be different, so we have to turn our smaller fraction, or the fraction with the smaller denominator, and make it an equivalent fraction so it has the same denominator as our other fraction. So I'm going to show you what I mean. So in this problem it says solve the equation below by making like units. So what we're going to do is, the great thing is in this first problem that you're going to practice, they already tell you what the like unit is going to be. So it's going to be, so you're basically 3/4 is going to turn into something over 12. So you can add the two fractions together. So if you remember, we've done this before. You take that smaller fraction, or the one with the smaller denominator, and you ask yourself, what did I multiply 4 by, or what do you have to multiply 4 by to get 12? And the answer is 3. So again, the rule, if you multiply the denominator by 3, you multiply the numerator by 3, and so your new numerator down here is 9. So 3/4 and 9/12 are equivalent fractions. But now you have two fractions with the same denominator, so it makes it easy to add those, and you get 10 over 12. All right. So I'm going to leave that kind of right there so you can still see it a little bit, and I want you to try this problem. So make that 2/3 into an equivalent fraction with this denominator so you can add the two bottom fractions together to get your total. Okay, so hopefully you did what I did up above, and you said, what would I multiply 3 by to get 9? And that would be 3. So if you multiply the denominator by 3, you multiply the numerator by 3, and you end up with 6/9, and 6/9 and 2/3 are equivalent. Now I can just slide the denominator over, add my numerators, and hopefully you got 7/9. All right, so you're going to have a couple of those to do today to practice, but then you're also going to have this one where they do not give you the equivalent fraction down here, or they give you the denominator, I mean. That's not a problem, because for today's lesson, all you have to do is, when you have this problem here and they don't give you anything down below, whichever denominator is a larger number, that's what's going to be your denominator down there, okay? So let me show you that again. So when you do one on your own, obviously between 5 and 10, 10 is bigger. So that's what your denominators are going to be. So notice in my original fraction 3/10, my 10 didn't change. So if nothing changed there, that means my 3 isn't going to change either. So you can just bring that whole fraction down. Now to find the numerator that goes here, it's the same steps. It's 2/5 is equal to something over 10. So again, oops, I already gave you the answer. So it's, what did I multiply 5 by to get 10? The answer is 2. So if I multiplied the 5 by 2, what am I going to do with my numerator? That's right, you're going to multiply it by the same number, and so you get 4 over 10. And so now I can just add those two fractions together because they have the same denominator now, and I get 7 over 10. Okay, so same type of problem down here. I want you to find an equivalent fraction for 1/4 that has the same denominator as 5/8, so you can add those fractions together and see what you get. All right, so remember, the fraction with the larger denominator, you can just copy down there. Then it's a matter of, remember they're going to have the same denominator. Then it's a matter of 1/4 is equal to what? What's my equivalent fraction going to be when I change my denominator? So again, it's 4 times what gave me 8? It's 2. So whatever I multiply the denominator by, that's what I multiply the numerator by. So there's my new fraction. 2/8 is equivalent to 1/4. And now I can add those together, and I get 7/8. So hopefully you did okay with that. As always, go back and watch the video if you need to, and please ask me for help if you're ever